In this video, I'm going to show you how to send your models from Revit into Blender using Speckle. Let's get started. Let's start with the requirements to follow this tutorial. You need to have 4 things. First, you need to have a Speckle account. If you don't have one already, go to speckle.xyz and create an account. Next, you need to download the manager for Speckle. Manager allows you to set your accounts and also install and update the connectors. Speaking of connectors, we're going to use 2 connectors from Speckle, the Revit connector and Blender connector. They are installed via Speckle Manager, and there will be cards in the top right corner of this video that shows how to install those connectors as well as how to install the manager. Go there, follow the instructions, and come back if you want to learn more about that. Okay, let's continue with sending our models from Revit. Here we are inside Revit, and I'll be using this basic sample project from Revit Sample Models because I want you to follow me. So if you have installed the Speckle connector, you should see a new tab in your ribbon called Speckle. Let's click on that and then click on Revit connector to initialize it. I'll start by creating a new project. Let's name this Basic Sample Project and click on Create. And then I will create a new model. Let's name this as Blender because that's where we're going to go from Revit. And then I will click on Send, which will convert everything from Revit, including the views, the materials, families and types, and all the 3D elements. Okay, data is sent. Let's view it online. And here it is, the same model from Revit inside the Speckleverse, inside the web. So next, we need to receive this data inside Blender. So let's switch over to Blender now. Okay, here we are inside Blender, and this is the famous default cube. And as always, I'll select everything and remove them. So if you have installed the Blender connector correctly and activated it, when you press N from your keyboard, you should see a new tab for Speckle. Let's click on that and then click on this button to initialize the connector. After initialization, I will select the project I created as well as the model and then click on Receive. You can also see the more information about the data you have sent, by who, when, from where, etc. And after you click Receive, you will see a couple options here. The first one shows clean meshes. By default, when you send your data from Revit, it is sent as triangulated mesh geometry, which is totally acceptable, but inside Blender, when it comes to UV mapping, you would want to see more clean meshes. This option merges coplanar faces, so you have more clean meshes inside Blender for flat surfaces. Next, we have how to receive instances, and by default, it is sent to collection instance. That is totally okay, and click on OK. And after a couple seconds, here is our Revit model inside Blender. Let's go over some of its features now. I will switch over to the shaded view. And as you can see, the first feature is the Speckle connector supports conversion of Revit materials into Blender materials. So if I were to select this topography and go to its material information, you can see its material is set as grass and its color is green. And this information is actually coming from Revit. So if I were to switch to Revit now and select the same topography, go to its material information, you can see it is grass. So the Speckle connector handles the conversion of material from Revit into Blender. And this actually opens up a great workflow. What you can do is you can override these Revit materials with PBR materials inside Blender for your visualization workflow. We're going to do that in the next section. Let's continue with the feature number 2. And feature number 2 is the outliner organization inside Revit. So if I were to zoom into this and select the collection and collapse it, you can see we create a collection for each Revit category and put relevant elements inside it. So now if I were to select, for instance, the walls category, right click and select objects, you can see the wall elements are selected. Let's isolate them. And here they are. Let's unisolate them now. So another feature of this collection organization is we automatically hide certain categories, such as rooms, assuming you don't really need them in this workflow. But if you really need the room geometry too, you can still access them. It's just a matter of unhiding it. Okay, so this was the feature number 2. And the feature number 3 is that we create a camera object inside Blender for 3D views from Revit. What do I mean by that? Let's select one of these camera elements, like this one, and zoom into it. And as you can see, this corresponds to this view from Revit, from Yard, right? Let's switch over to Revit now. Go to Project Browser and open the 3D view from Yard. And as you can see, it is the same view. So we are preserving the camera location and rotation information. In the future, we are planning to expand this camera support to include other properties of views from Revit too. So these are the features of this workflow. Let's try to demonstrate some real life scenarios now. So we are assuming that you're going to be using Blender for visualization workflows, and I'm going to quickly show you how to override the default Revit materials with some Blender materials. So for that, I will quickly switch over to the shading tab and select one of the topographies like this one, and use Ctrl-Shift-T from my keyboard because I have Node Wrangler enabled. And then I will override this boring grass material with some PBR materials I downloaded from web. So I'll select these and click on Principled Texture Setup. And here it is. It looks a bit ugly. That is because the UV mapping of elements from Revit are not set. So we will do that manually in the next step. But first, let's set up more materials for some other stuff too. So I'll quickly switch over to this one and select one of these faces to override the roof cladding material with some PBR materials I downloaded. Okay, that is also set. Let's switch over to the wood planks now. And again, do the same thing, Ctrl-Shift-T, and click on Principled Texture Setup. Currently, looks like nothing has changed, but it actually changed, and I will demonstrate to you in this section now by setting the UV mappings of elements. So let's quickly switch over to the UV editing tab now. And inside here, I will also switch to the shading view just to better see the effect we are giving into the objects. So I'll start by setting UV mapping for the topography. So let's select this one and select all the faces here and the UV mapping and smart UV project and click on OK. And here it is. You can see the texture being applied. And also here, I will switch this map to the albedo so we can actually see the effect that is taking place here. So let's make this a bit bigger so those grasses, they don't look so ugly, right? I think this is more reasonably sized. And here it is. Now the same material looks much better. Let's do the same for the roof cladding too. So I'll select the roof element, go to edit mode, select one of the faces, and then select all the materials and do UV and cube projection. And here it is. Let's quickly switch over to the albedo map. And then I'll scale this up to have a better effect. And here it is. Let's do the same for these guys too. So I'll select all the elements that has the same material. And then get into edit mode, select one of the faces, and select all the faces with the same material. Go to UV and cube projection. And these wood planks are horizontal and I want to have them vertical, so I'll simply rotate them in the UV mapping editor and then scale it up. And here they are. So the beautiful thing about this workflow is the UV mapping is preserved for unchanged objects, right? So what I will do is I will modify one of the elements in this wall, maybe add another window here, right? And then send that from Revit again. Let's do that. So I'll quickly switch to Revit now, go to 3D view, zoom into this window and do create similar. And let's move this a bit sideways. And here we have another window. Let's quickly go to Speckle tab and click on Send again. Okay, data is sent. Let's quickly switch back to Revit now. Go to Layout and refresh by clicking on this button to get the latest information from Speckle. Again, I will select the model and click on Receive. And as you can see, I can see more information about the data I sent. So I'll again select the clean meshes and click on OK. And as you can see, right, the textures are still here and there are no duplicates, right? And the UV editing and the UV mapping I did for the roof is still there. For the other walls, they are also still there. But for this wall element, which is actually modified, I need to reset the UV mapping. And that's acceptable. And let's do that. So I'll quickly switch over to the UV editing again. Select one of the walls, do Shift G and select all the materials. And from here, I'll again do cube projection. And inside this dialog, I will simply select the albedo map for the wood planks, rotate it 90 degrees, and then scale it up again. And that's it. So this is one workflows we enable. You can create your models inside Revit, send them to Speckle, receive it in Blender, and set your materials, for your scene and add any assets you think are necessary. And speaking of assets, another workflow we enable is replacing Revit assets with Blender assets. So what I'm going to do to demonstrate that is I will select one of the trees in this model, like this one, right? And replace it with a Blender tree. So these are instances coming from Revit, right? There are multiple families in this model with the same family type. And we are creating collection instances for that inside Blender. So to access the original geometry, we need to switch over to the Blender file and then select the relevant original element. But first we need to know the collection name. So let's select the tree, and then inside outliner, I'll press comma from my keyboard to reveal it in the outliner. From here, I can see its instance ID as well as it is type ID, right? This is the type ID, RPC3, Deciduous, and then 39, D871, etc. So let's quickly switch over to the Blender file. And then here, I will open collections, go to RPC3, and then 39, D8, etc. So this is the collection that is being used for that instance. So what I will do is I will right click on this and then say link to scene. And once I do that, there will be a new tree element in the origin of this model right here. Oops, let's get into the model quickly and select it. And then I will isolate this. And also I'll quickly switch over to the view layer again and press comma in my keyboard to reveal it in the outliner. And here is the RPC3 collection. So what I want to do now is I want to replace this boring tree with some Blender assets. So let's quickly do that. Let's do Control-C and Control-V, and here is the new tree. I'll quickly scale this down to match the size of that tree. And then inside the outliner, let's quickly zoom into there. And inside the outliner, I will delete the old geometry. And now this tree looks much better now, right? So let's quickly unisolate everything to see the effects taking place, right? All the instances of the same tree are now replaced with the tree we defined inside Blender. Another cool thing about this workflow is this also updates when you have a new version coming from Revit. So let's quickly showcase that. I'll switch over to Revit now, and then I know this was, let's actually disable the section box to see all the trees, and here they are. And then I'll select the tree family I modified inside Blender and add more instances of that into my model, like so. And this is actually Honey Locust 25. So let's select one of the trees, and then I will isolate all the trees in my model Select all of them, like so, and then replace it with Honey Locust 25-inch. So now they are all the same tree that we have modified inside Blender. So let's quickly send this version to Speckle. And here it is. Let's click on Data Sent to view the latest version. And here it is. If you're not aware, I've been talking about versions, models, projects, etc. That is because how Speckle organizes its model structure. So you have the project, that is the biggest container. And then inside the project, you have a model. If I were to get into this model, I can see the different states, different versions of my model. As you can see, the first time I had 628 objects. Now I have 636 because I've added more elements into my model. So let's quickly switch over to Blender now and receive the latest version. And here they are. Now all the trees in my model, they look exactly the same as the other trees. And the beautiful thing is I have replaced the Revit trees, the boring trees, with some good looking Blender assets. So we think with this workflow, you can create your designs inside Revit, and then when it comes to visualizations, easily replace the Revit family components with more realistic looking material sets, high quality Blender assets. So this was it. We have highlighted different features of the connection we create between Revit and Blender using Speckle. We highlighted how Speckle supports materials from Revit, as well as how it organizes collections inside Blender to match categories from Revit, and also how we convert 3D views from Revit into Blender cameras, while still updating the new versions coming from Revit. Give this workflow a try. If you encounter any issues, let us know in the comment section below, or the better option is letting us know at speckle.community, our forum. Thanks for watching, and I'll see you in the next one.